No, this one is mine, the other one is not. First and fourth.
Okay. Thank you very much. Good evening, ladies and gentlemen. My name is Radim Brixí. I come from the Czech Republic, from Europe, from Central Europe, okay. And my topic is human prediction of computer-generated value based on statistical experimental approach. So this paper is going to focus on measuring of intuition in human-computer interaction research. First of all, I would like to consider some researches which were done before already. I prepared my presentation for 15 minutes. You don't give me 15 minutes, so I will be quicker on this one, right? So, okay. The first experiment was about the correlation between group of people who were meditating on the wish that there should be less murders that day in the United States. And there was measured a correlation that a group of people were close in the room, they did the meditation, and they found out that there was a correlation between the number of people who were murdered that day. So that's a pretty interesting correlation. This is Roger Nelson's Global Consciousness Project, which you might be familiar. They have got like random number generator cells all around the world, and they are looking at the correlation if very important events all around the world that correlate with randomly generated data, and they are focusing on the strange behavior of the random generators during the time where something important happens. So it's about the global consciousness, and my paper is something like to be focused on the single individual level, that we are looking at the consciousness of one person, and we are looking at the interaction with the computer, and we are looking at the difference whether when the human interacts with the computer can be found something strange different than if the algorithm or program simulates something with another program, okay? So what's the idea? I would like to present an experiment that I've done, and the idea is that the spiritual people come across phenomena like insight or prediction or intuition, which shouldn't be present in case of algorithms or programs, because they should be basically made in such a way that they cannot guess in different way than on random basis. Okay. Paper is focused on the ability and possibility to predict generated value, even though no information about the generated value is obtained by the user through physical senses. So the idea is the computer generates a value. I have no information about the value what the computer generated, and now I'm supposed to guess the value, right? So I have only non-relevant information. I have no information about the value. We test whether the cognitive process can lead to better statistical results than the theoretical probability, right? So if we would say there is no effect, it should tend to be like the probability value, right? It should be the same. I am presenting here the paper where I have measured that it's not quite the same. The difference is not big, it's very slight, the difference, but it's measurable, and I will show you just in a minute the results of the experiment. The very important thing is that in my experiment, the experiment is constructed in such a way that you as the human are trying to guess as much best as you can, right? It's very important to say at the beginning that we do it in the way that if you can guess it or not, that you are supposed to try to do your best. It's very important at the beginning in case of this experiment. So you should guess as much as possible. So the construction of experiment was created that I created an application with possible generation of buttons. There can be n buttons from 2 to 99, and it depends up to you where you start to operate with the application, how many buttons you choose. Usually I've chosen 3 buttons, sometimes 6, sometimes 9, sometimes 25, it depends on the situation. For better statistical analysis, it's more practical if you have less buttons. In case you have more, it's no problem if you have more steps of guessing, right? So the thing is that you have to go through many steps to measure something, right? If you have 2 little steps, then it has no sense. So therefore, I decided to have at least 80 steps of measurements. If the user is successful, you count it as successful attempt. And if the user is not successful, it's obviously unsuccessful attempt, but the application informs the user what was the originally supposed button to be clicked in order to create something like feedback of learning which one it really was. Nevertheless, I have more information about which it was. So it's providing even the feedback in all cases where I click wrong. And it reads the button which I was supposed to click in case I had the wrong shot. The user goes through many steps as possible and tries to do the best. The minimum number is 80 and the maximum depends on the user, how he feels and whatever. It depends on the experiment run. I managed to do not just 1 run of the experiment, but obviously more runs of the experiment. Okay, now we see the screen of the application. This is the screen of the application. You have got 3 buttons. You hit wrong, so the green one here is shown. I can show you now even the application itself if you want, by live. Okay. I have to do this. So this is the live version of the application, not live like live, but it's the application itself, right? So it's in VBA macros. I've programmed it in a way that you select number of buttons and then you start to play this game. It's quite easy. Okay, then what's your tip? Which button? 2. Number 2, okay. And you are correct. Success. What's your next tip?
No, there's no tip. 1.
1? Okay. You were not correct. The correct was number 3. So you have to learn and click number 3. Okay, next tip. Sorry?
2.
Number 2. Very well done. So here you have 2 successful attempts from 3, and we would go so on and so on and so on. Here we have got the average. The theoretical average should be 1/3. In this case, when we had only 3 steps, it's obviously quite high, 0.666, but I use statistical test that counts with whatever number in case we have more than 80 steps, right? So the test criteria is 1.65 approximately, and your score is 1.22, so you wouldn't be able to prove your result now because it's 2 little steps now, which takes into account my statistics, right? So I will just move the application back, and I will continue with the presentation to show you some results. Before I show you the results, I must explain the statistics that I used. Of course, we can talk about the binomial way, but I have created this statistic because we can approximate it by normalized normal. So the thing is that the hypothesis 0 is theoretical 1/3. The alternative hypothesis H1 is that we have got a result which is greater than the 1/3, right? The test criteria is to use this one. So when we use this criteria, then the significance level alpha is 5%. It means that we can be 95% sure that the result that I show are telling that it is the way I present, right? And the 95% is not bad, okay? In some cases, I've also measured on the 99%. So the critical value, if you want to be sure for 95%, is 1.645, okay? And now let's see what we have measured, right? Okay, 7 runs. Number of steps in the test run. Some are long, some are short, but actually some are quite long, right? The test criteria value is higher than 1.645, which means that we must accept the alternative hypothesis that the value is greater than the theoretical value, because in some cases you see it's really much higher. In some cases it's not that much higher, but it depends on the test. But the funny thing is that when you play the game and you go, I've observed that I am able to manage the level which is above the criteria. Sometimes in less steps, sometimes in more steps, sometimes it just flies around, but basically this value should just flow somewhere around 0, plus something, minus something, about 0. If I try, I'm basically quite often above the 0, which is not what is supposed to be, right? Measured average score, okay, it depends on the number of buttons. So in those cases, we had 3 buttons. In this first case, we have got 6 buttons. So the theory is 1/3, which is 0.33333, and the value measured was 0.45, which is quite higher, but it is only 83 steps. So that means that the test criteria is more strict, but even though it's quite high, 2.4. Okay, maybe it's just a coincidence. So I did also some very much longer tests, where you can see that the value is still above 1.645. These results are in the paper 111, and they are actually in the table over there. I managed to do more tests, even though I have submitted my paper. So since the time I've submitted the paper, I've done more new tests, right? And the values of the test criteria are here greater than 1.645. And I have managed to do tests with many number of steps, like 200, 1,000, 2,000, and I've managed to done also one it's very hard for the concentration, but it was 10,000 steps, which is really a lot. And those 10,000 steps had the value 1.9, which is pretty much higher than the 1.645. Okay, here's also the list of the rest. And finally, let's look at the criteria and the results. So if we are above the red line, we are 95% sure. If we would like to be 99% sure, it's much harder. But yes, those light greens are very much even above the 99%, which is very much proof of that there is something happening with the interaction of consciousness and the system. Okay, what is the conclusion? The thing is that I have measured, when I was performing the test with the application, that the theoretical value is not necessarily in all cases of human interaction with computer, and there may be some events where the result of interaction is not purely random. So the user may be able to predict and decide right with no relevant information obtained through the human-computer interface. It is consciousness responsible for the measurable difference. Okay, we can discuss now what is behind it. But the thing is that in these days we have more complex systems, every systems are much more complex and we don't understand them. And we have to manage those systems, we have to control those systems, and we should understand the systems. But as the systems are getting much more quickly, bigger and harder to understand, and the skills of people are maybe slightly better, but not that quickly better as the systems are growing, we have to face the situation in the future where we will have to decide about the situation and about the systems, which we have nothing, we don't know anything about the system, but we will have to decide. Because this is the situation we will face on the daily basis in not very far future. We will have so complex systems, and we have to even though decide if we have no information in like European Union about some things that happen in the countries around. Okay, in this case, we can see that we can even though have slightly better chance to make a right decision, even in such case where we have absolutely no relevant information to the thing. There are some other experiments we were testing that even the non-relevant information may lead you to better results. So I just take point like that. There may be many causes of why is this happening. But the thing is, I have measured that this is happening, and now there's the question, what can we deal with that and find the reason? Okay. 10 minutes? Okay, thank you very much. Now that's the place for the questions. Okay.
All right. Have you considered different types of feedback? So you're only using the visual senses at the moment. What about the other senses? Instead of showing a green feedback, what about sound? What about other sensors? Have you considered those?
Well, my point of view is that you just need whatever kind of feedback, because the brain is quite capable of taking into account whatever kind of feedback.
Yes, but is there a difference? That's the question. Is there a difference of the different types of sensors you have?
Of course, everyone has got different skill of controlling mind, of visualization, of acoustic visualization and all those things. So this is very individual. But in general, we will have to make a test which uses different kind of feedbacks and then compare the results, which I have not done, so I don't know. I just done the green button feedback.
Okay, and the next question is, what if you have two different good results, and by that you can start basically mind control. You can steer to the green answers or the red answers. So you can choose which type of answers you want.
So like you mean that you would play the other way around, right?
No, not just the other way around, but you have multiple true values. You have the green values and the red values, and you consciously decide which ones you like. I like the green buttons only, maybe.
So you are focusing that maybe green is not good color for
feedback. What if there is green and then there is red also, and you pick only greens?
Well, I don't know. I have just constructed the test in this way. So
might be part of future work.
So if we decide that we construct the test the other way, and there are many other ways how we can construct the test, then we can discuss if it is possible to create the test in such a way that you will have maybe 4 buttons and 2 are correct and 2 are wrong, right? And this issue is in this application managed by the thing that I will just move you the application back so you can see it. So if you wish to have like 50-50 chance, you just basically click on the 2 buttons version and you click the fixed value test. If you wait a bit, then it generates just 2 buttons and you are like 50-50. If you would like to play the game in the less chance, like 9 buttons, then the probability is 1 divided by 9. So you can scale the test in such a way that it's comfortable for you, because the test and the statistics is based on the principle that I'm proving that it's not necessarily in all cases random, because I am proving it by the case which is different, which means it doesn't work in all cases, right? Okay, thank you for your questions.
Other questions?
Other questions, yes?
It's another thing. We use many algorithms, we develop our algorithms, and there we put various cutoff points, thresholds, right? Intuitively in many occasions. With human intuition, we put a threshold value, cutoff value somewhere, say 0.2, 0.5, 0.001, that way, and that works very well. Does your hypothesis give a support to it?
I